All right, people, we are on 8-4 math message, but it's in our journals today, so page 261. This one's called Setting Up Chairs. These are one of Miss Schmidt's favorite things to do because you see we have clues today, and they're going to help us solve a problem. It's like a mystery or a riddle, and I love to use clues to solve them. Sometimes they might seem really difficult, but if you use things you know and you break apart the clues, that helps you understand it more and eventually get an answer. So we're going to look at one today. Okay, it says Miss Soto is setting up chairs for math night. Her room cannot fit more than 35 chairs. She places the same number of chairs in each row. As she sets up the chairs, she makes up a problem for her class with these clues. Okay, clue A. When there are 2 chairs in each row, there is 1 leftover chair. Clue B. When there are 3 chairs in each row, there is 1 leftover chair. Clue C. When there are 4 chairs in each row, there is still 1 leftover chair. And clue D. When there are 5 chairs in each row, there are no leftover chairs. Use these clues to figure out how many chairs Mrs. Soto sets up. You might be thinking, there is no way we can solve this, but you would be incorrect because there's actually more than one way to figure this out, and we're going to, first of all, see what we know. So what is this telling us? Well, we know that there can't be more than 35. Does there have to be 35 exactly? Nope, there can be less than 35 chairs. Can there be more than 35 chairs? No, because her room can't hold anymore. So we know it's going to be 35 or less. We also know there's the same number of chairs in each row. So if I have a row of 8, my second row has to be 8 in them. Maybe with 1 left over, sure, but they have to be the same in each row to start, minus the leftovers. And then she sets up the chairs. She makes up this problem. Okay. Let's break apart clue A. When there are 2 chairs in each row, there is 1 leftover chair. Okay. Let's see. When you multiply a number by 2, what do we know about that answer? Think about if I have an odd number times 2. And think about if I have an even number times 2. What is my answer always? Well, I know that 7 times 2 is 14, and I know that 6 times 2 is 12. So my answer is always even, but what do we know about clue A? No matter what, there's 1 left over. So 14 plus 1 or 12 plus 1 or any even number plus 1 is always odd. So we know our answer of total of chairs has to be an odd number. It cannot be an even one. That's what clue A is saying. Okay, so we know it has to be odd. When there are 3 chairs in each row, there is 1 left over. So that means we could draw a picture, and when we have rows and we put 3 in, 1's left over. When there are 4 chairs in each row, there is still 1 chair left over. So if we draw a picture of rows and we put 4 chairs in each, there's still 1 chair left over. And let's see, when there are 5 chairs in each row, there are no leftover chairs. What is that clue telling us? Well, let's see. Think about when we multiply. Oh, there's no leftover chairs, so it has to be a multiple of 5 because each row has 5 in it. So think to yourself, what do multiples of 5 end with? Think if we go 5, 10, 15, 20, 25, 30. What does that last number end with? There's 2 of them. Okay, then it says Joey, one of Miss Soto's students, makes a conjecture that Mrs. Soto set up 13 chairs. What is that word, conjecture? Maybe it's something like you've heard of before. Well, A conjecture is an educated guess or a claim, we can call it. So it's kind of, he made a guess using these clues, educated guess. Okay, we know it's an odd number. Well, he said 13, it's odd. You know, and 13 is less than 35, so is that a pretty good guess? Yeah, it could be. And we're going to figure out if he is right or not. So he made a conjecture. It says work with your partner. You're going to work with me. Use the clues to make a mathematical argument for or against Joey's conjecture, his guess. You may draw pictures or use counters to show your thinking. Explain your reasoning. Okay, I also see mathematical argument. Do you think that's an argument like if you have a sibling and all of a sudden you're like, I know you ate the last fruit snack? Is that the kind of argument we're talking about? It's not. When we have a mathematical argument, it's us using reasoning to tell whether this conjecture, this guess, is right or not. So it's like we're solving it to see if it's true or false. That's a mathematical argument. So one way we can show if Joey is correct or not is we can use these clues and his answer and test his theory, his idea, his conjecture to see if it works or not. So let's see. He has 13 chairs. When there are 2 chairs in each row, there is 1 left over. Okay, so here's my first row. I'm going to use a raise. And remember, each row has to have 2. So I'm going to go, okay, my first row has 2. Then I make row number 2, and there is 2 chairs in this row. So here is row 1, here is row 2. I have to keep going until I reach 13. Can I go over 13? Nope, I can't. So I'd have to stop right before 13 if I need to. Row 4. See, 4 times 2 is 8. 5 times 2 is 10. I'm making an array. You can see that. 1, 2, 3, 4, 5 times 1, 2. So we're at 10. 6 times 2 is 12. Can I go any further? Well, no, because 12 plus 2 would be 14. So let's see. I have 2 in each row, and if that's 12, and then I draw 13. Did I have 2 chairs in each row with 1 left over? Well, look at all of these rows have 2 in them, and I have 1 left over. So far, so good. Joey's is going pretty good. Here was clue. I'm going to put A above it. I'm going to keep my work very organized. Okay, clue B. Let's see, remember it says when there are 3 chairs in each row, there is 1 chair left over. Okay, so here is my first row, and I have rows of 3. So I'm going to keep going with my rays. 1, 2, 3. And maybe I'm already thinking, I know that the fact pair 4 times 3 equals 12. And let's see, what was my other hint in clue B? That there had to be 3 chairs in each row with 1 left over. Well, if this is 12, 4 times 3 equals 12, and this is my 13th one. So far, so good, right? This one, our clue checks out, and clue B works too. Okay, that means we have to try clue C. When there are 4 chairs in each row, there is 1 chair left over. 4 chairs in each row. Oh, look at that. We had 4 by 3, so now I'm just going to do a 3 by 4. I just used my facts, but I flipped them around. It's like fact families. They still work because look at how many do I have in a row? 1, 2, 3, 4. 3 times 4 is 12. And my clue said I'd still have 1 left over. So 12 plus my extra is 13. Does clue C fit? You betcha. Okay, time to choose our last one. Do you think Joey got this right or not? When there are 5 chairs in each row, there are no leftover chairs. Well, here's row 1. Let's see. 1, 2, 3, 4, 5. Okay, row 2. Oh my. Row 2. 1, 2, 3, 4, 5. Okay, let's figure out my array. What do I have so far? 1, 2 times 5. 5 times 2 is 10. Can I fit another row of 5? Well, 10 plus 5 would be 15, but I can't go past 13. So how many do I have left over? 10, 11, 12, and 13. Does that work for clue 2? When there are 5 chairs in each row, there are no leftovers. Did he have leftovers? Oh, he did. He had 3 leftovers. So does that work? It doesn't. So was 13 a right answer? No. So we just did a mathematical argument. We solved and we figured out that his conjecture was not correct. He didn't have a right guess. But you know what clue told us this wouldn't work? Well, when there are 5 chairs in each row, there's no chair left over. There are no leftover chairs. What are factors of 5 again? 5, 10, 15, 20, and so on, because I know we're pretty good at counting by 5s. Well, what do factors of 5 end with? 5, 0, 5, 0, and so on, and 5 and 0, and 5 and 0. They're going to end in 5 or 0 the whole time. Does 13 end in 5 or 0? No, so right away we might have even known that 13 doesn't work. Okay, in your packets, in your worksheet packets, we have the same problem and we're going to find some solutions for it. So you can go and watch the other videos and follow along in your packet.